Okay, we are picking up in 2.6 notes. I recorded this yesterday too.
Okay.
For you. And we ended with this example. We were finally getting into graphing. I like this example because we didn't have the canceled factors of x minus 1, which meant there was a hole at x equals 1. So I just reminded students, when you sketch this graph, make sure you did indicate that there was a hole there at x equals 1. Because in my original function, I could not plug in 1. I would get a case of dividing by 0, which we can't do. And then my leftover factor of x plus 5, that indicated where the vertical asymptote would be. Okay, so you have 2 examples down, 4 to go. Another one. First, can I simplify this?
Yeah.
Yes, the bottom factors.
Yeah.
So that's what we check first. Nothing cancels here, but this does help me now in this factor form to find my vertical asymptotes. That's what I check next. Reminder, that is whenever your denominator, whatever's left over, is equal to 0. So I end up having 2 at -2 and 1. Can we cross vertical asymptotes? No siree. These ones, our graph does not touch or cross. All right, next thing I ask myself is, do I have any horizontal asymptotes? So this is when you look at the degree of the numerator and the degree of the denominator, and it looks like the degree of the numerator, which we usually use like little n, is less than, because it's a degree 1, the degree of the denominator. Denominator is degree 2. Do you guys remember what that means for horizontal asymptote?
Y equals 0.
Y equals 0. You guys are so smart. All right, then we also look for those slant asymptotes.
Wait, isn't there no horizontal?
Correct, yeah, there can't be both. So there is none here. And our kind of like rule for slant asymptote is that the degree of the numerator is exactly 1 more than the degree of the denominator. We just said it's less than, so there's no slant asymptotes. And Connor brought up a good point. There cannot be both horizontal and slant. So you don't really have to write that down, but I'm just walking you through my checklist. Oops, I have 2 number 2s. Walking through my checklist of things I check for every time when I'm graphing. First, second, third, fourth. And then lastly, we find intercepts and plot some extra points if we need to. So I just start with my x-intercepts. That's when y is 0. I'm going to use that factored form. Times both sides by my denominator, I get an x-intercept at 0. Which also obviously counts as a y-intercept. And obvi, you don't really have to show this, but when I find my y-intercept, or f of 0, I'm going to get 0 for that as well. So that's my only x and y intercept is at 0, 0. That's the only time it should cross my axes. Okay, so we're going to definitely need to plot some more points here because we only have 1 intercept to go off of. So remember, the strategy is to pick them around the vertical asymptotes. Okay, to the left and to the right of all the vertical asymptotes. So I also mentioned last class that you can use the table feature in your graphing calculator to help you with this instead of having to plug these all in. And I'll do these for you quick. So I plugged in like -4 and -3, just like a couple to the left of that asymptote. Then I definitely plugged in -1. Obviously, we already did 0, 0, so I don't really need to do that again. I plugged in 2 and 3 just to kind of give me an idea what's going on around the asymptotes. All right, here's what I got. And again, I'm okay with decimals in your table. Okay, so obviously we're getting a lot of decimals. If you wanted to change the scale, You could, okay? You don't have to though, because a lot of the end behavior is pretty easy to draw in here with the asymptotes. Asymptotes are our guides for graphing. So I'm not going to change the scale at all. 1, 2, 3. -4, -0.4. So I kind of know what's going on here. They're going to just approach the asymptotes. Okay. -1, I got 0.5. 2, I got 0.5. 3, I got 0.3. So again, I kind of know what that's doing. Now this middle piece though is a little interesting. So if you needed to plug in more points, like you could plug in half if you wanted to. But you can see it's definitely like going up, approaching this asymptote. And that's what vertical asymptotes do. The end behavior goes off to infinity or negative infinity. So maybe just to be safe, plug in a point here. You'll get out a negative value, so your graph kind of goes down here and approaches negative infinity there. So this one kind of has like a little middle piece to it. So you can have 3. Yes, you can have like 3 pieces.
I'm sure.
Yes, and you can even have 1. We'll do them like that. Crazy, right?
These graphs only have 1.
Okay, we're finally going to do one with a slant asymptote next. We haven't done one like that yet. Okay, any questions? The nice thing about these, and obviously, guys, if you're still not sure, just keep plugging in more points, okay? The nice thing about these, though, is, like I said, they approach the asymptote. So after you plot a few points and kind of just connect the dots in a curvy fashion, your pencil should kind of like feel like, oh, yep, this is where I need to go here, approaching the asymptotes. That's what I like about these graphs. Okay. Obviously, you can always check your answer too by putting this in your graphing calculator. Here we go. We finally have one where our degree of our numerator is bigger than our degree of our denominator. So first things first, I see I could factor the top, the numerator, into x plus 1 times x plus 2. However, nothing cancels. Since I have that factor of x minus 1 left in my denominator, that means there is a vertical asymptote at 1. If my degree of the numerator is greater than the degree of the denominator, that means we have no horizontal asymptotes. And if it's exactly 1 degree greater in the numerator, that means we have a slant asymptote. Oh yeah, here we go. Okay. So as a refresher, what we do to find slant asymptotes is we do the division problem that's set up in my rational function. Or I do my numerator divided by my denominator, because every fraction is really just a division problem. But, don't get too whiny yet. Look at my denominator.
Oh, I love this problem.
I can do synthetic division, right?
Sure.
Yeah, I can do synthetic division because I have a degree 1 polynomial in my denominator. Okay, so we can do, it's a bit quicker. Let's do synthetic division with using 1. And then obviously you're going to have to look up here. 1, 3, 2. All right, now remember, you do get remainders. That's okay. 1 times 1 is 1. Add straight down, I get 4. 1 times 4 is 4. Add straight down, I get 6. There's my remainder. You kind of just ignore that. What you're looking for is the linear polynomial that's like your quotient, your answer. So this ends up being 1x plus 4. Obviously 2, what we know is synthetic division. If I do a degree 2 and I do division with degree 1, it's always going to drop a degree. So 1x plus 4, so I have a slant asymptote here at y equals x plus 4. And your slant asymptotes, folks, those should always be linear. They should always be linear. All right, so y-intercept of 4. And don't put like a bunch of dots on here to get this line, maybe just like a couple, but I don't want you to think that these are part of your graph. But just give yourself a couple. Y-intercept of 4, slope of 1 to be able to draw in that asymptote. Okay. Next, I check for intercepts. So I like to use that factored form. It's easier to solve. Multiply both sides by x minus 1. I get here. And I'm like, hey, I got two x-intercepts at -1 and -2. Seems odd. Let's see if I got any y-intercepts. Find f of 0. That might be easier to plug in here if you want to, or you can plug it in the factored form, doesn't matter. Either way, we get 2 over -1, which is -2. So I could probably draw in this piece, but obviously those are only values to the left of that vertical asymptote. So when I make my table, I want to make sure I definitely pick some points to the right. I'm going to come up here to do my table. So I plugged in, where are we here, number 4? 2, I got 12. 3, I got 10. And 4, I got 10. So let's go ahead and do that. 3, 10, 4, 10. 2 was 12. And if you want to change your scale, you can, but I'm not too picky right now. Maybe let's do one more. What about me do 5? I didn't do this one yet. I could do this in my head, but I'm just going to quick do it in my calculator. 25 plus 15 plus 2 divided by 4. 10 and a half. All right, so then we're like, we can connect our dots here in a smooth fashion and approach the asymptotes. This one's going to go up. Here, connect the dots. So if there's 2 x-intercepts here, it obviously kind of just maybe barely comes up. Approach the asymptote. Approach the asymptote. So you can kind of still see like the shape of this rational function, but it's just kind of like smushed a little bit. And it's because we don't have a perfectly horizontal asymptote. Now we have this slant asymptote. So it still kind of forms that branches curve to it, kind of. But it's just like smushed a little bit because of that slant asymptote. Isn't that cool?
Oh, that's just so cool.
I like the slant asymptote ones. I think they look funky. They're so fun. Okay, we're halfway done already. 2 down, 2 to go. Do you want to do them on your own, or do you want?
I want you to do it.
He's a guy. Nope.
It's just more fun when we do it all together, right?
Yeah.
Yes.
You just get to hear how excited you are.
Okay. Can this one be simplified?
Yeah. Difference of squares.
Oh, I see it.
Difference of squares.
Oh, that's what I can think about.
However,
Yeah, the difference of cubes.
nothing cancels. No problemo. That just means we're going to have a couple vertical asymptotes here. At -2 and 2. Cool. Oh man, that's just not very sure. Let's try that again. Degree in my numerator is greater than the degree in my denominator. So what does that mean for horizontal asymptotes?
It's not.
No horizontal asymptotes, but because it's exactly 1 greater, we do got ourselves a slanter. Why do I keep doing number 2 twice? All right, now we are going to have to do long division on this one. because my divisor or my denominator is x squared minus 4. Okay, so I'm not going to do my work over here. I personally like to put placeholders in both my divisor and my dividend. So I'm taking x cubed. So I like to do this. And I'm dividing it by x squared minus 4. Now, you don't have to do placeholders in the divisor if you don't want to, but again, it just keeps everything nice and lined up and nice and organized. So I just always recommend that you use as many placeholders as you want, or as you need, I guess, not want. Okay, so now I do my long division, and I would have x, and I would get x cubed plus 0x minus 4x. That's a nice, short and sweet one.
Yeah, it is.
Oh,
Those cancel. Here we get positive 4x plus 0, which that's my remainder. So my slant asymptote is just y equals x. The line y equals x. That is our parent function for linear. Goes right through the origin, slope of 1. I could have done this side a little bit better. I got a little flat. Slope of 1. There you go. Obviously, it's just kind of slice your graph right now. All right, now we have our asymptotes, our guides for graphing. Now we get to just plot some points. And always find the intercepts. Let's see here. 0 into my factored form. I get x cubed is 0. 7x intercept at 0. And that's also my only y-intercept. We don't need to go through the work there. Okay. So for my table, want to plot points around the asymptotes. So I picked -4. My usually general rule is do 3 to the left of each asymptote. Not 3, sorry, 2. I was writing down the number 2. 2 to the left of the asymptote and then 2 to the right. So 2 to the right of this one, I did -1. Obviously, we already did 0. Definitely plug in 1. And then 2 to the right of that other asymptote, so 3 and 4. All right, here's the numbers, squad. -5.3. -5.4. -1 is 0.3. 1 is -0.3. 3 is 5.4. Seeing a lots of symmetry here. 4 is 5.3. Which again happens a lot in these. Okay. Plot a lot. Obviously 5.3 and 5.4 are really close, but obviously try to make one lower than the other. -1.3. Or change the scale if you feel the need to, but I think we have enough info here to be able to sketch in our curve because of all the asymptote patterns and symmetry with these graphs. All right, I'm going to draw this in blue. So what ends up happening, connect the dots, approach the asymptotes. Here we kind of get one of those weird middle pieces again. Connect the dots, approach the asymptotes. Here's an example of crossing a slant asymptote. Remember, you can cross slant and horizontal asymptotes. Here, connect the curve, approach the asymptote. Whoa, I like that one.
Me neither.
They're all special in their own way. Just like you
You're
guys.
special, right?
Special.
You are the gross.
Oh,
All of the above.
Drink till we go.
Okay.
Anything.
One more. You guys are doing great. One more. This one's kind of.
Sounds like a nurse and she's about to give you a shot.
You're doing great.
Yeah. It's almost over.
Okay, last one.
Just breathe.
Or the dentist.
Last thing of notes for the whole week. This week.
Oh, yeah.
Ooh. Is my numerator factorable?
All of the above.
Yeah. How does that factor?
X squared minus
Wow.
1, X squared plus 1.
Well, the baby cancels all that. Kind of ridiculous.
That's like, yeah, we don't have holes.
Yes. And I can actually keep going here. I have another different squares, right?
Yeah.
So I'm not exactly sure what Carter just said, but I think he said, why do we have to factor it? Is that what he said?
Huh? What?
Did you say, like, why do we have to factor it?
No,
No.
he said
If nothing-
nothing cancels. I said that's good because I don't have to worry about holes.
Oh, got it. Okay. I thought you were saying, why do we even have to factor it if nothing cancels? But
No,
you
I
were
said
said,
nothing cancels either.
we got to
It's
look for
disappointed.
holes. Yeah. Okay. You guys are so great. Vertical asymptotes. Looks like I have 2, again at -2 and 2.
Having two vertical
That's kind of
All right, this one's kind of a weird one. My degree of my numerator is greater than my degree of my denominator, which means there's no horizontal asymptotes.
That's by 2. So there's no essay either.
Exactly, but it's by 2. And it has to be exactly 1, so there's no slant asymptotes either.
No essay.
Okay, so let's check for intercepts. Okay, oof. I'm gonna plug it into my factored form because half of my work is done for me.
Oh, you don't even have to worry about that one because that's imaginary.
See, you guys can do something on your own. Obviously, multiply both sides by the x plus 2, x minus 2. We get here. This
but it becomes up to wrap up.
is 1. This. Oh, sorry. -1. That one's 1. This
Looks like it's just going to go
is
through.
going to give us imaginary. So we don't need to do anything with that.
So I think you're right.
Go ahead, plot those. And then y-intercept, f of 0. This one would way be easier to just plug in here.
Mhm.
We get 1/4. So either change your scale or just mark this here. Okay. Probably don't really need a table, but better just double check our thinking here. And I heard Connor say, looks like we're going to need a parabola. Well, when we have a degree 4
It's that.
divided by a degree 2,
It comes out.
what kind of polynomial am I going to have left?
Binomial.
Right? 2. Subtract the power. So
That sounds like.
it does form a parabola.
That work.
All right, here though, I just plugged in like a couple other numbers in between my. That one's obviously a 0. You don't need to plug in your intercepts into your table. I guess the only new ones there are 1.5 and -1.5. But that just kind of confirms that yes, it does. Ooh, that's not -2.3. Whoops. No. 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 Okay, I'll try it. I feel like that don't work sometimes. Oh, good call, Ashton. Thank you. All right, so -1.5, -2. That just kind of confirms, yep, this is going to be forming this shape. Approach the asymptotes.
Oh, that was a lot easier than last time we did.
Right.
We should have started with that one.
Yeah, we should have.
I appreciate your feedback. I will put it in my notes for next time. Okay, that's 2.6. Thanks for watching.
Time to go.
I like how you keep lying.
Taking
If
a
you
nap.
enjoy your life.
Yeah.
I mean, it is work.
I think you should go back to
I mean,
geometry.
Sleeping is work.
Geometry is the hardest math class.